Hey guys, this is CodedSteele, and at long last, I am bringing you another App Inventor tutorial. My apologies for taking such a while to get you guys another video up. I've had a lot of stuff kind of going on, and I've also I have been responding back to a few of you who have made requests as to apps that I should be or that you would like to see operating or working or whatever. So I have been keeping track of that stuff. I do have another few apps in mind. I think the next app we're going to do is going to be a text-based app. I'm going to show you guys how to use a Wi-Fi connection to do text-based stuff. But today I figured I was going to do a game because we haven't really done a lot with the canvas element. So I figured, you know what? I kind of want to show that off. So I'm going to go ahead and show you guys all about the canvas element today. And pretty much this whole app is going to make use of the canvas element. It's going to show you guys how to do rudimentary collision detection. And I guess it's not actually rudimentary because it's actually the way you do collision detection in this. It's pretty much the only way. You can create your own form of rudimentary collision detection, but I really advise against it because it's not going to be better than the collision detection that they already built into App Inventor. So I would just use their collision detection as it works pretty well. Couple of things. First of all, obviously, thank you guys for all the continued support. I really do like to see all these apps that you guys are coming up with as far as what you would like to see me do. I have done a few of you guys' requests. But I kind of figured this one wasn't a request. This one was just me kind of wanting to show you guys something different for once. It's kind of returning to what I kind of wanted to do for an app or wanted to show off for an app. I wanted to show off a game. And I figured this would be a pretty cool game and a pretty simple game at that to go ahead and show you guys how to build. So that is why I did that. All right. Yeah, then let's kind of get through it, get into this, and I will show you guys exactly what this game is and what it does. First of all, ignore the scatter that you see on this screen here. It doesn't really look like this. The game isn't going to look like this. I structure it in the block section instead of doing the structuring in the designer section. And the reason I did that was because it's a little hard to position. This designer is pretty terrible with positioning sprites. So I figured rather than go ahead and go through the BS of sitting here trying to get all of these things positioned correctly, I knew exactly what location they needed to be in. So I just hard coded them in the block section to align themselves in the correct spot. This is just me placing them on the screen and just to make them exist. And then when the screen's initialized, it will automatically position them in the correct location. I have that all programmed to do that. So, and we will see that here in a second. So first of all, in order to create a game, you have to create sprites. So where do we do that? How do we do that? Well, first of all, the ball sprite, we're lucky enough, is actually built right into the drawing and animation tab. We have the ball right here. So basically, I use the ball straight from that. But first, before you do any of that stuff, I think I've explained this in past tutorials because we have used the canvas. I have used the canvas in a previous tutorial. I think my random color generator thing used a canvas, and I think maybe one other app used a canvas too. But so you would drag a canvas in here, and my canvas, I have it filling the parent. Why? Because it's a game. It's going to take up the entire space of the screen. We don't want it to take up, smaller parts of the screen or anything like that. So I have it set to fill parent, blah, blah, blah. Now, this is where we run into some issues. You can draw stuff on the canvas. Like if I go into the block section, you guys can see clearly under the canvas section here that I can draw a circle, or I can draw a line, or I can draw certain points. I can draw text, and I can do all of that stuff. Here's the problem. App Inventor does not by default call those sprites. It doesn't call those sprites. That, I think, is kind of a flaw in the software to me, because I would think there should be a way for you to actually mandate something's a sprite. I understand about the background stuff. Sometimes you don't want stuff to interfere with the game. But if I was going to draw a line, there should be an option on this line for like another thing below Y2 for called like make sprite. And you should be able to set that to true or false. And then if you set it to true, then it has a sprite name. And then you should be able to also have some text to name the sprite, whatever you want to name it. But obviously that's just me talking about what I wish was part of the software, and that's not what actually is. So just keep that in mind. In order for collision detection to work, unless you want to create your own rudimentary collision detection, which you could draw this line simply enough using the draw a line function of the canvas. However, it is not considered a sprite, so you would have to turn around and create your own collision detection for it, which I originally did, but I kind of backed off on because, first of all, it was extremely complicated to turn around and do it, and I had only gotten the collision detection working with the first bar, and then I was going to have to make it work with the other 19, and I figured, you know what, no, let's just turn around, make our own sprites, and then use the built-in collision detection to make it like 1,000 times easier. So that's what I did. And the way I made my sprites, first of all, I have this sprite and I have this sprite. These are really the only two sprites that I use. So I have, I have this sprite, I have this sprite, and I think those are my only two sprites that I do have, right? New pixel 4, yeah. And new pixel 1. I don't know what this new pixel.gif is down here, but I don't think I need that. I don't know. Anyways, all right. So what I did, I had to create my own sprites. Where I did that was in this new www.pixel.app.com. So I went ahead and I used this to create a sprite for my games. It's pretty simple. It's pretty simplistic. I don't think you can actually get really, really complicated with it. It did the job. It created sprites that I needed. I wanted to create a little goal zone. Well, I was able to create a goal zone, and I wanted to go ahead and create a line to serve as an obstacle, and I was able to do that really simply in this piece of software. I'm not going to spend a lot of time on this because you guys can figure it out yourself. It's not really hard to use. If there are any questions about how to use that later, we can address that later, but this is not a tutorial to try to show you guys how to use the software. So I created this and this in that app, or in this Piskel here. Piskel software here. So now I have those two sprites that I need for my game. The other things that I did, obviously I dragged the ball in, and then I uploaded, using the upload file key, the two Piskels, or they're actually called sprites. I don't know why I'm calling them Piskels, but the two sprites that I created in this Piskel software, and I uploaded those and put those on the screen. So the other thing I did also was you needed to drag the accelerometer sensor, the orientation sensor, and a notifier component onto the screen. This is just me, like I said, creating my game, so you guys will follow me here in a second. You'll see exactly where this is going as to what this game is actually going to be. So once you do all of that, you guys can see also that I needed to create 20 sprites, actually 21 sprites. The 21st sprite is the goal zone. The other 20 sprites are all these lines. So I have 20 lines that are going to take up the screen. That was pretty monotonous to go ahead and drag all of those lines on here. It's just a repetitive task that I did, and it is a pain, but I got it working. It works great. I'm probably going to go ahead and I'm going to source this app on the screen, or I'm going to at least make all of these GIFs downloadable so you guys can use them to make your own app or improve upon this app, whatever you choose to do. And then I drag the ball into the canvas element as well. So that's pretty much all there is to the structuring. The most pain part of it all was these image sprites. Obviously, you can see there was a lot to that, but once you get all of that structured, not really that bad. So now we've got to start coding the logic part of this thing. We've never discussed the accelerometer sensor before, and this is just a bunch of block of stuff that I don't even use, so that can just go in the trash. All right, yeah. Let's talk about how we turned around and got this game structured. First of all, By default, App Inventor wants to change the screen orientation every time you rotate your device, your phone or your whatever. So anytime the screen orientation is changed, I fix it back to the landscape mode so it won't change or won't rotate at all. So I do that there. I had this variable called enable movement. You'll see exactly what that does here in just a second, or how that works. Then we have this acceleration change block, these collision boxes, and notifiers. We're going to talk about that later. This is what I want to talk about at the moment right now. This screen one.initialization. This is the structuring for the game. This is how I give the game its structure. So what I did is I turned around and I set all of the image sprites here. This is where I do my organization for it. So there are 21 sprites, and this is me setting their location for each and every single one. Now I'm going to discuss how a few of these work, and then I think you guys will get the idea. So there's 20 of them. Kind of what I wanted to do was space them 1/20 to take up 1/20 of the screen. So how I did that for positioning them was I said, okay, well, I want the first one, the X position of it, I want it to be, take the whole canvas length, which is the length of your device, the length of your screen, divide that by 20, and set that to where the first image sprite is going to spawn at. And then I want you to turn around and I want you to do this. I want you to figure out what the height of the canvas is, which you actually know the canvas height. Subtract that from the image height, image sprite one.height, and then place that sprite there. So it might not be straightforward and obvious as to what that's doing. This, I think, is obvious. We're going to replace the X coordinate of it 1/20 of the screen. That's pretty straightforward. So if this whole screen was wide, 1/20 might be like right here. So, okay, now you know my X coordinate is going to be somewhere in this length of the screen. However, now we got to do the height. So the height minus the image sprite height. So what I mean by that is, this is the height of the canvas. Let's just pretend this is a canvas, and this is the whole height of the canvas where my mouse is moving. If I take that and I subtract the image sprite height, I am essentially trying to make it to where I position the sprite to where it will run until the bottom of the screen. Hopefully that makes sense to you why that is. Basically, okay, if the sprite is 500, if the canvas is 580 pixels and the sprite is 80 pixels, we want, or the height of the sprite is 80 pixels, we want it to start at the 500 and then it'll print until the bottom of the screen. So that is my way of positioning this first one at the bottom of the screen. That's what this does. This controls where it will be positioned. That'll be more clear to you once I demonstrate to you guys the functionality of the app. And then obviously this is just the 20th of the screen. The second sprite is something different. I divide by 10 here. Okay, hopefully you guys know enough about your math that dividing by 10 is the same thing as this being 2/20. This is 1/20, this is 2/20. So I just kind of did my math that way to simplify it and whatever. So I get sloppier with my math later as I go down, but eventually the layout works itself out and everything will be good. And then I set the Y location here to 0. So basically I'm telling it, start at the top of the screen and print it down however far you need to go. That one's simple to understand, I would think. 3, we go back to the bottom of the screen. 1 and 3 are similar. The only difference is that instead of it being at 1/20, it's at 3/20 of the screen, and it's going to print at the bottom. 4 is the same as 2. 5 is the same as 3. 6 is the same as 4, so on and so on and so forth. All the way up until the last sprite down here, which is image sprite 20. And image sprite 20, we're placing that at the edge of the screen, the canvas one.width. So we're telling it, okay, you're going to spawn right here at the edge of the canvas. And then we're going to go ahead and we're going to place you at the 0th location as well. So I think that actually probably doesn't show up on the screen, or shows up on the way edge of the screen, so it's probably not even visible on the app. But that's okay, whatever. I just have that there, and it's there. I think if you removed this, it would be the same. The screen would look the same as it's going to look, but whatever. The last thing we need to worry about now is this image sprite 21, which is our goal zone here. This is our goal. Our goal, we want it to be positioned somewhere on the end. I had a hard time, obviously, trying to get it lined up on this stupid layout thing. So I said, screw it. I'm going to go ahead and code it just like I did with the lines as well. And how I did that is I said, okay, well, how big is the image sprite? The image sprite is this wide. The canvas is this wide. I want it to be positioned at the end of the canvas. So the way I did that was say, start printing at a point where your image begins, and it will run until the end of the canvas, if that makes sense, how I explain that. There probably is a better way to explain that than what I did. But it's the same thing that I did here with the height. I'm trying to make it run until the edge of the screen on the bottom. This one I'm trying to make it to run to the edge of the screen on the right. And then I position it at 0 because that's the upper left-hand corner. That's where it starts printing. Perhaps that's another thing I should have mentioned. When I'm saying move to, it's moving the upper left-hand corner pixel of the sprite to that location. All of the other pixels will follow because you're moving that upper left-hand corner, but you're setting the reference point for the upper left-hand corner, and then all the pixels will print out the rest of the way. So you're just setting essentially where the image is going to start printing, and then it will print however big it is across the rest of the way. So that's how the move to command works. It takes the upper left-hand corner and places that where it needs to be. So pretty straightforward there. Nothing really, hard. Hopefully not hard to understand about how the screen one is working, but that's essentially how that all works out. All right, so that's the layout of the screen with the goalpost and everything. The next thing we need to discuss is the ball and how we're going to go ahead and add our physics movements and all that stuff. The ball is the one thing that I did not set in the layout because I was able to physically code its position as 0, 0 right there, no problems with that. So that actually worked pretty well. It starts at the 0, 0 location, all is well and good. Now, let's talk about how the ball moves. The ball will move based on how the accelerometer is functioning. So since the phone is in landscape mode, that means that the phone is rotated to the left. As you guys can see here, the phone will be on its side and it will not be straight up as it usually might be when you guys are doing something. So it's rotated to the left. And so when it's rotated to the left, its orientation is changed. The accelerometer remains fixed, but its orientation is changed. So now your Y becomes your X and your X becomes your Y. So what I mean by that is the accelerometer does not change. We changed this. This stuff works. The X is the same. The Y is the same for the ball. That's not going to change. But the accelerometer, however, needs to change because the accelerometer does not move with the screen orientation. If that makes sense how I explain that, hopefully it does. Let me explain it again. The accelerometer does not move with the screen orientation. So meaning your X is going to remain the same, your Y is going to remain the same, and your Z is going to remain the same for the accelerometer. So when we change it to landscape mode, you're changing the way your Y and X behaves because now your X has essentially became your Y for the accelerometer, and your Y has essentially became your X for the accelerometer. That's just how it has to work. So that is why the ball is going to move based on how the phone is rotated. And for those of you guys who do understand what an accelerometer does, it's essentially that thing when you hold your phone and you rotate the phone, it makes the thing in the phone move or the object in the phone move. If you guys have ever played a game where you've had to rotate your phone, that's using the accelerometer inside of your phone to move the objects. So that's essentially what we're doing here is we're saying we're moving the phone and that's moving the X and Y position of our ball. Everything else image sprite wise will remain fixed, and that's essentially how that will all work out for us. So the next thing we need to discuss here is this enable the movement thing. By default, enable movement is going to be true. So we're just going to talk about that later, the enable movement later. However, we do need to talk about this here, the collision detection. This is the built-in collision detection that App Inventor makes use of. So what we have going on here is when this ball 1 dot collided with occurs with anything other than Sprite 21. What's Sprite 21 again? Sprite 21 is the goal zone. So if we collide with anything besides Sprite 21, we're going to move down here and we're going to reset the ball location to 0. This is basically saying you lose the game. So when you hit any of the other 20 sprites, sorry, you're going back to position 0, 0. That's just the way it's got to be. So the ball goes back to position 0, 0, and you got to start the game all over again. However, if you reach the goal zone, hooray, you did it. You're great, blah, blah, blah. Now it's going to ask you, the notifier component's going to come up, and it's going to say, would you like to play again? And then blah, blah, blah. You'll have a selection, play again, nope. And then, so those would be your 2 selections that you have here. This cancelable basically means I'm trying to make it to where you can't cancel it. You have to either say play again or nope. And if you say nope, it'll close the app. If you say play again, it'll start the ball back at 0, 0, and you will go again, as that's shown over here. So after you choose one of these 2 options, if your choice was play again, the ball is going back to 0, 0, and then you're going to play again. If not, you're going to close the application. Here is where the global enable movement thing comes in. So what I have to do here is, as soon as you win the game, we would have to stop the ball from moving. Why? Why do we have to stop the ball from moving? Well, because by default, when the notifier component comes up and the text box comes up on the screen, the app is going to continue to run in the background. When I'm rotating the phone, it's going to continue to try to change the ball location. We don't want that to happen, because if the ball collides with something, technically you lose, or with anything other than the goalpost, you lose. But if it collides with the goalpost again, we can see what's going to happen here. Collides with the goalpost, make a notifier come up. Collides with the goalpost, notifier, notifier, notifier. So if you went ahead and you hit the notifier like 50 times, you're going to have 50 notifier boxes coming up. We don't want that. That's going to crash your app potentially, or it's going to slow it down. So we need to stop that from happening. And the way we do that is by saying, don't move anymore. Hey, turn the movement off. Everything's good to go. And then if I give you the okay, no, what am I doing there? If I give you the okay to turn the movement back on, then you can start moving again. But until then, don't do anything. However, if you say, nope, I don't want to, you're going to close the application. That is essentially all there is to the app. It looks a lot harder to maybe code than it actually is. It's got 1 level, obviously, because you guys didn't see me coding anything but the 1 level. If I wanted to, I could go ahead and I could turn these all into procedures and create layouts for every single level. I could turn this into a full-blown game or something like that. But this was just supposed to be a demonstration. It's not supposed to be showing you guys how to create, a completed game. This is just a simplistic, how do I get started with programming a game? Where are we at with time? Great, we have enough time to show off the app's functionality. Here is the game right here that I created. So the ball's at the bottom of the screen because, and it's going to look a little glitchy on the computer. It's not on your device, I promise you. On the device, it actually moves pretty smoothly. But let's see if I can actually beat it. Right here, nice and slow, nice and slow. So I'll show you guys a collision later, what happens when you collide with the wall, but for right now, all I'm trying to do is just get to the end and actually show the end thing, because this takes the longest. So it's not really too bad because everything's positioned, equidistant from each other. So it's not like it's once you get used to it, it's like, I screwed up. Dang it, I failed. Okay, so there you go. You guys saw the loss right there. I mean, it's not, like I said, it's not a really hard to do kind of thing. Once you get used to it, it's a pretty easy game to play. Come on. It's not too often I get to turn around and play a game in a tutorial, so. Come on, come on. And did we do it? Oh, yeah, we did it. So you guys can see I made it to the goal zone. It asks you if you want to play again. If I say play again, it's going to set me back to the location over here. If I say nope, it will close the app. It's supposed to close the application, but apparently it didn't want to do that. So you guys can see exactly what it was supposed to actually go ahead and close the application. As far as that, there might be some kind of a hiccup in here, probably with the get choice play again. Anyways, whatever. It's supposed to close the application, and it didn't for some reason. Whatever. Anyways, if I click play again, or click cancel right now, apparently it's going to set you back to the beginning. There is a way to turn around and do that. We'll probably discuss that in a future tutorial as to how that is supposed to have, or how that was supposed to have worked. So anyways, though, that's how you create a simple game. Pretty straightforward, nothing real, fantastic to it. If there's anything else that game-like you guys want to see done, or because I pretty much showed you collision detection, all of that stuff. If there's anything else you guys really would like to see an example of in order to help you create your own game, feel free to leave a comment and explain in detail, or send me an email and explain in detail what exactly it is we'd like to see. And obviously check out this pretty nice piece of software. It's free online, and you can go ahead and you can create your own sprites that you can use for your own App Inventor game. So, all right. Anyways, that's all I have for you guys for this tutorial. Please like, comment, subscribe, and as always, thank you guys for watching, and I hope to see you guys in a future tutorial.